Okay, so let's finish up this 10 items or less section 3.1. On a graph, which axis represents the rise and which axis represents the run? Maricela, what do you think? Okay. Okay, so x-axis is run, y-axis is rise. Anyone want to challenge her authority? Anyone get a different answer? No? Okay. And it makes sense if you look at it visually. You have this as your x-axis, that's your y. If you're running, you're not going up and down. You're going right and left. So it would be x-axis for run. And rise would be up and down. So it would be your y. Okay. Number 2, if the slope is 0, what would this look like on a graph? Rami. Straight line? Oh, okay. Good job. So it's not just a straight line, it's from left to right, and it has to be completely flat. So this way, if I pick 2 points, let's say it was here and here, my rise would be 0. My run would be 1, 2. So this would be a slope of 0. Okay, what would this look like if it was a car and the slope was 0? What would be happening in this situation, Luis? Okay, just sitting there. So if we were measuring speed for the y-axis, so this is time, this is speed, and I say from this time interval it's flat, that means the car is at the same speed. So, oh wait, does that mean that he's going 0 miles per hour? This is speed? So what does it mean? Okay, that he's going at a constant speed. If he stopped, it would be from here to here. So if I made another graph and changed the label, and I say time and distance, and I make it look the same, does it mean the same thing? What does this mean? Okay, that's how far, that's how fast. So this one would be a constant speed. So we could, on this one, say we're going 60 miles per hour, right? Here, would it be 60 miles per hour? What would it be? 0, the distance changed, right? So 0 on the distance changed. So they look exactly the same, but just changing this label changes the whole meaning of it. All right. Okay, go ahead and copy that down so you have a few examples, because it was open-ended on whether the labels, what were you even measuring. So copy that down. Okay, what is the slope of a line with the rise of 7 and the run of 3? So if I write the fraction, what's on top? 7. So we put the rise on top. So it's always rise over run. So this would be 7 over 3. Do I want to change this to a whole number and say 2 1/3 though? You could, but which one's easier to graph? 7 over 3. Now let me show you the difference, because you could even go further and say this is 2.33. Now if I were to graph this, you could either go up 1, 2, 3, 4, 5, 6, 7, and then over 3, and then put your point. Or you could do this, go up 2 1/3 and over 1. Here's a 1 right here. So you could go up 1, 2, estimate a third, go over 1. Up 1, 2, estimate a third, and then over 1. And you could continue that way. Or look at it as up 1, 2, up 0.33 over 1. So you could get the same answer either way, but we like the fraction form because it's just counting, no fractions on there, right? So we're just going up whole numbers rather than going up fractions. But it's important to know the difference because if you ever run into that problem, you would still know how to tackle it. So you just make this over 1, go up that amount over 1. Good? But for this class, you won't really run into that problem, so just make sure you keep it as a fraction. Okay, let's scroll down. Draw the graph to the following situation. Draw the graph to the following situation measuring the height of a basketball that is dropped on the floor. Okay, so what did you say it would look like? Show me with your finger. Okay, so here's Luis's answer. What kind of ball is that? It would bounce. It's not a weight, right? So it's a basketball, so it bounces. So what does it look like when it bounces? Bunch of M's. Okay. And all you gotta do is put your XY axis. Sometimes just how the situation looks is how it'll look on a graph. If you're measuring time, what do you think this is measuring? It tells you in the problem. Height. So depending on this label though, it's going to change how it looks. Try to make yours look a little bit neater than mine. Okay, number 5. Draw the graph to the following situation, measuring the amount of water in a bucket that a hose is filling at a constant rate. Okay, so we're measuring in a bucket, and this is going to be time, and we'll say amount. All right, good. What happens before I start at 0 seconds? It's empty, so it should be at the origin, 0, 0. Okay. What's a constant rate then? It has the same, use the word, same what? Slope. So constant rate, circle this on your paper. Write that means it has the same slope. So all you have to do is give me a slope and then count the rise and run and see what it looks like. So pick any slope. Give me a number. Okay, 1/2. Any others? 3/4. Wow, everyone's giving me right answers. Any others? Nothing? Aureliana, give me a number. Slope. Yeah, that'll work. Remember, you can pick any slope because I just need a slope to start with. I'll pick the half. I go up 1 over 1, 2. Go up 1 over 1, 2. So it's a constant rate, so that means the slope never changes, right? So as long as you pick any slope and then you graph it, this is what it would look like. It doesn't tell you how fast it's filling up. So it's just going to be a line though, because the rate of the hose never changes. So we could say at 1 minute, every 2 minutes it fills up 5 gallons. right? So if it's 3 minutes, 4 minutes, this is now 10 gallons. What do you think this one is? 15 gallons. At how many minutes? 5, 6. So that's what it means to have a constant rate, same slope. Okay, go to section 3.2. 3.2, this one right here. Our objectives for this section, we have to understand when a relation is a function. Be able to describe a function in terms of domain and range. So your domain and range, go ahead and write this on your paper. Right, domain is your x, range is your y. To get this section, you need to know that. What's your domain? What's your range? Y. Oh, let's see, look, you got some followers now. Look at you. Be able to represent relations and functions as ordered pairs in a table, an XY table, as a graph, and in a mapping diagram. So we're going to take the same information and we have to be able to see it as ordered pairs. That's where you have something like 3, 2, right? In a table, so that's something where you have a table XY, you plugged in 3, you get out 2. As a graph, well, that would just be plotting it. So 1, 2, 3, 1, 2. Go ahead and copy this in a mapping diagram. So mapping diagram, you make one bubble here. This represents your x's or your domain. And one bubble here, and this represents your range, which is your y. And put 2, and you just draw an arrow saying that when I plug in 3, I get 2 out. So those are the 4 ways we're going to be going over today. And then for that first one, we'll be starting with the definition of what is a function. Who else has that song going in their head? You know that song. No? Well, I'm not going to sing it to you if you don't know it. You know what song. Don't you play with me. Just trying to function. All right. Was anyone still copying? Everyone good? Okay, go ahead. Which 3? This x? Right here? Domain. Domain and then x. Okay, go ahead and turn the page. Let's go to the next part. Story time. What? You guys knew it was going to happen, huh? Oh, you didn't? You're still excited though, right? Yeah? Yeah? Okay. So, story time functions. So this is how we're going to explain story time. Or functions, I mean. So once in an ordinary classroom, see, I have this reading voice I use with my kids, so you guys get to hear it. There were 3 boys. Okay, too much. And 3 girls, which made 3 happy couples. Everyone, what, you guys don't like story time? Go, Okay, you did it inside, I could tell. So you have Joe, Bob, Andy, Jane, Bree, and Abby. They're all holding hands. They were so happy that whenever they went to a function, they were the function. Until one day, Joe held Jane's hand, and Joe held Bree's hand. Bob and Andy still held Bree's hand, and Andy held Abby's hand. What? Who do you think is at fault? Who? Who's bad?
Joe.
Joe? What about Bree?
Joe and Bree.
Joe and Bree? So Joe was caught holding hands with not just Jane, but with Bree too. Shame, shame. The three couples no longer went to functions, then they were no longer a function. So Joe stopped holding hands with Jane. One would think that Joe's move to stop holding hands with Jane would not fix the problem, but Bree was allowed to hold hands with Joe and Bob. They were once again a function, and everyone lived happily ever after except Jane. She became a cat lady. The end. Now wait till you see how this is related to math. We just learned the definition of a function. Anyone confused what happened with the story? What? You don't get what happened? What happened?
I know that Joe's player and James won.
Okay. That was the quick way. I should have just said that. All right. So let's discuss the difference between the two ways to visualize this story. So this right here is answering our first objective. We're understanding when a relation is a function, okay? And we're also looking at how we can visualize it in different ways. So once in an ordinary classroom, there were 3 boys and 3 girls, which made 3 happy couples. And then we can look at this story as Joe and Jane here. So Joe and Jane represents the same thing as them holding hands. Everyone see that? So Bob and Bree are holding hands, so I could write it as the coordinate Bob and Bree. So I'm going to jump ahead because it seems like you guys are understanding this. So if I had this instead of Joe and I put a number 2, and here I have Jane, we'll say is 3, this would represent 2, 3 as the coordinate. So that's how it's related to math. So Bob and Bree, if I say 5 and 7, right? This would be 5 and 7 is how I could represent it. Andy would be 2, let's say -2 and 4. I don't want any of the numbers to repeat for this example. -2, 4. And that's how we could look at that. So now, look at each one and how we have all of our names now written as coordinates. So here, they're still a function, right? Why is it that they were not a function at this point? So right here is when they became not a function. But over here, they became a function. So talk with your groups. Why is it that here it's a function, but here it is not?
By plugging in the numbers, right?
Okay, Jonna, who made it not a function? Bob and Bree. Joe? Oh, okay, so scroll down. On this part, there's still a function on this last scene right here. So Joe still is allowed to hold hands with Bree. So who is not a function?
Jane.
So when Jane held hands, they weren't allowed to. Right? Okay, so hold on. I was confusing myself with all the names. I work in numbers, guys. I don't work in names. So back to Jonna. She gave me the right answer from the beginning. So Jonna was saying that it was Joe. So Joe's not allowed to hold 2 people's hands.
So X can.
But J, there we go. Yeah, we're making the transfer now that this is X, this is Y. So go ahead and write that that's X, that's Y. And this is how it's relating, is that X can't have two Y values, but Y can have two Y values. Genius. Okay. So X can't have two Y, or they can't have two Y values, but Y can. All right. So Marcella. So which one cannot have two Y values, X or Y? Is that a question? Which person couldn't have two values? X. But what was the person's name on this? Joe. So Joe represented X. He can't have two Y values because when a guy tries to hold two hands, they always get caught. Girls are more sneaky with it, right? Wait, we're outnumbered here, Luis. We shouldn't talk like that.
I see what's going on here. Guys can have two girls, but girls can have two guys.
Right. Right. I didn't say it. He said it. I'm all about equality. Okay, let's look at this. So now we're going to do some practice, but we're going to go to actual numbers. So let me do the first one with you and show you how to write a mapping diagram. So when you're writing a mapping diagram, you're going to make your X values your Y, and you're only going to write the values one time. So same way as on that story time, I didn't write Joe twice. I didn't draw a picture of Joe twice because he's holding two hands. I only wrote it one time. So we have a 3, a 4, and a 7. Do any of those repeat? No, so we're going to write all three of them. 3, 4, 7, and then draw a bubble around it. Now for the Y, we have a 2, a 3, and an 8. None of them repeat. Draw a bubble around it. And now same way as how they were holding hands, we're going to draw arrows from the X's to the Y. So when I was at a 3, what did it go to? The 2, 3, or 8? 2. What about the 4? 3. 7? 8. Okay, so same way as story time, is this a function or not a function? Function. So no X's are holding hands with two Y's. Okay, next one. Yeah, we answered everything. All right, so we have X. Okay, so X values 7, 8, and 6. Do any of them repeat? No. So we're going to write 7, 8, 6. Circle them. If it repeats, you still only write it one time. So here's an example. Don't write this. If I had 8, 3, I wouldn't write the 8 a second time, but I would write the 3 again because it didn't repeat. Or not again, but I would write it on this one. So I would write 4, 2, 2, and then I would write the 3 also if that coordinate was there. Does that make sense? Yeah. So I wrote this one as an example. You don't have to write it. But you see how the 8s repeat? I didn't write another 8 down here. I just have an 8 there. It's the same as if it was a person. You wouldn't draw the person twice. But over here, 3 is a new person, so you would put the 3 down also. Because you have 4, 2, 2, 3. The 3 didn't repeat, so you have to write it again. Let's take this out. All right. So 4, 2, 2, circle it, put a Y, and let's start getting used to writing this, domain, range. That's a huge concept. You always want to know your domain is your X, your range is your Y values. And draw your arrows. So 7 goes to 4, 8 goes to 2, and 6 goes to 2. It's not always going to be straight across. It's just because we're on the beginning examples that it looks like, oh, I just draw arrows straight across. You have to think about where you're pointing. Function or not a function? Function. All my people are happy. All right. Number 3. Do you think you're ready to try it on your own? Okay, I'll give you a couple minutes. If you run into any problems, check with the people around you and have questions ready for me in a couple minutes. So number 3, we were saying that it is not a function, right? So if I put 2, 3, and 8 for the domain, I'm going to stop saying x. We're now going to say domain. What is domain, guys? X. So I'm not going to say x anymore. Get used to domain is x. So you have 2, 3, 8. And 2, 3, 8 for your range. What is range? Y. So write 2, 3, 8. What does 2 go to? 2. Happy couple, right? What does 3 go to? 3. Happy couple, right? What does 8 go to? 8. Happy couple, right? Were there any couples that were cheating on each other? No. No dirty dogs. All right, so this one is a function. So the only time it would not be a function, here, let me give you an example. Don't write this down. Let's say it said 2, 4. Uh-oh, look at this sassy 4 coming in out of nowhere. Oh, no, the 2 is a dirty dog. This is now not a function. So if we add that, that's where it's not a function because your domain is cheating on one of the ranges. Good? Did I make a fool of myself for a good reason? Did that help? No? Okay. Well, whatever. I'll still make a fool of myself. It's not a big deal.
No, I didn't.
No, whatever. Message received, Luis. Okay. What did we get for 4? Function or not a function? Okay, I agree. What did we get for 5? Function or not a function? Not a function. Good, I agree. 6? Function. Okay, so without doing the mapping diagram, I'm going to show you how I'm doing it quick. You need to know how to do the mapping diagram, but it's good to know how to do quick. -1, -7, 4. Any repeating? No. So this one is going to be a function. -8, 2, -8, 2. Any repeating? Yeah, 2 and -8. So if those numbers are different, 6 and 3, and 1 and 3, so now this one is not a function. So as soon as you see that the x is repeating, red flag right there, it's probably not a function if the numbers are different. Now if it's something like this, I don't think it will happen. But if it looks like that, and the coordinate repeats twice, say you're taking data, and the coordinate repeats twice, this one is still a function, because it's just really showing you how much they love each other. All right? Okay. So 4, 3, so 4, 2, 8. Any repeating? No, so this one is going to be a function. So that's a quick way to do it without the mapping diagram. But you need to know mapping diagram for your exam. All right, prompt and summary. Let's do it as a group to move on quicker. What do you know about functions? What makes a set of coordinates a function, and what makes it not a function? Make sure to answer the prompt in terms of numbers, coordinates, and x and y values. So I kind of did a quick preview. How do you know right away if it's a function or not a function? I just did it. Good, you didn't even say x. The domains aren't the same. Okay, so if the domain, if they are not the same, is it the function or not a function? Okay, so if they're not the same, then it's a function. If you find a domain that repeats, it's a function. Good. I think that's the one thing I want you to take away. So we're going to move on to the review of substitution. So this part, if you were to do the packet out there, you wouldn't get to see this review. But you need to know it in order to find out what the range is given a domain. Okay, let's do the first one together. This is how I like to approach it. Whenever I see an x, because I know I'm going to substitute that in, I put parentheses where I have the x. Marticela, what should I put in the parentheses? Two. Good. So you got that from right here. There's a 2. I saw an x right here. Since x is equal to 2, I just plug it in. The way you guys should approach this is always put parentheses first. That protects your operations from staying the same. So add parentheses, take away the variable, take the variable, plug in. 3 times 2 is 6, 6 plus 2, y equals 8. Go ahead and work on the others. I'm going to rotate around and just check your papers. We won't be doing this one on the board, so the quicker you do this on your paper, the quicker we can move on. After you're done, call me over so I can check your answers. Present. So f of x, on those problems, it was, from the last one, it was negative 2x plus what? 2? So instead of writing y equals negative 2x plus 2, all I would do is say f of x equals negative 2x plus 2. So this f of x is the same thing as y. So write this, f of x is the same as y, which is your range. So domain, range, you could say range f of x. What is domain? Which values? X values. What's range? Which values? Y values. Okay, why do you use an XY table instead? So if you look on the previous review problems, what was the benefit of having that, the XY table? Would you rather say write down the problems 4, 5, and 6 from the last one, or just 7? Okay, so if you look at it, 7 included all of the same things from 4, 5, and 6. It was just a quicker way to write it and organize it. Now here are 2 ways that you can organize an XY table. So the first way is if we have this problem y equals 3x plus 4, we could say x, y, I changed the y to an f of x, plug in negative 1, 0, 1. And then you would do side work and find out that your answer for negative 1 is 1, answer for 0 is 4, answer for 1 is 7. Everyone following? Good? Now on the other one, you don't do your work on the side. Work is part of the table. So you leave room in between and you write out negative 1. Then you say f of negative 1, which means when I plug negative 1 into the function, I get 3 times negative 1 plus 4. Negative 3 plus 4, 1. And write it here. So basically, instead of doing the work on the side, you do it in the middle. You can do either way, but all work must be shown in your problems. So you got to figure out whether you like it as just a table or like seeing the work in the middle. Is there any questions on how to organize your work? No?
Basically, just however I want.
Yeah, you can choose either way, but that's why I told you either way, all work must be shown. So for the work that you do, you still have to show, just don't do it in your head and be fine with that. Okay. All right. Okay, let's go to investigate part 1. What does a function and a non-function look like graphically? So let's plot the coordinates 2, 4, 3, 1, 2, 2 on a graph and tell whether it is a function or not. If it is not a function, connect the points that make it not a function. If you need to use a mapping diagram to help you find the coordinates that are not on a function. Alright. So if you need to, use a mapping diagram to help you find the coordinates that are not on a function. Breakdown. Plot the coordinates 2, 4, 3, 1, 2, 2 on the graph below. So instead of reading this whole paragraph, I broke down the steps that we want to try. So go ahead and plot 2, 4, 3, 1, and 2, 2 on the graph right now. Let's resume. Okay, so when you plot it, you have 2, 4. So your first one should be up here. Check that you plot 2, 4 here. 3, 1. 3, 1. X is always first. And the Y. 2, 2. 1, 2. And 2, 2.
2, 1.
What's that?
That's 2, 1.
What's 2, 1?
Sounds harder.
Oh. Thank you, sir. 2, 2. There we go. Thank you. I was like, what are you talking about? Alright, so 2, 4, 2, 2, and 3, 1. Now, if we went back to what we've been learning about the mapping diagram, do you see any dirty dogs? Anyone that's holding hands that's in the domain? 2? Okay, so you saw that the x's are repeated. So this 2 and this 2, right? So that's this coordinate here and this coordinate. So is this a function or not a function? Not a function. Okay, so you could even circle it if you don't want to write it. So not a function. So now our instructions are to connect these points. Go ahead and draw a line through these points. As straight as you can. This is hard doing it on here. Let me face forward. What's that?
Just the 2, right?
Yeah, just through those 2. Okay. So this one would be not a function because we were able to draw a line through it. Now, if you were unsure, you could create a map diagram like we did before, but we were able to answer it without. Connect the coordinates on the graph that make it not a function, if any. We did that. Now, what does function and non-function look like? Plot the coordinates 3, 4, 1, 2, and 4, 2 on a graph. So go ahead and try this one on your own. Go ahead and try it now. Alright, so let's plot this real quick. Luis, let me know if I mess up. So we have 3, 4, 1, 2, 4, 2. Okay, so it should look like this. Did you see any numbers that repeated? No, so would this be a function or not a function? Function. So go ahead and circle function. Now, if it was not a function, it said to connect the points that made it not a function. It's a function, so there shouldn't be any lines drawn here. What do you notice now, going back and forth between the two, of how you could have a test to show whether it's a function or not a function? So here's your question that you have to answer right now. What did you notice about the location of coordinates on a graph when it is not a function? How can this help when given a graph and asked if it is a function or not? So let me give you an example of what kind of graph you will run into. So if I gave you something that looked like this sideways parabola, how could you tell me whether it's a function or not, even though I didn't give you any actual coordinate values? So write that down, don't say it. Use the past 2 pages. That tells you what kind of test you could run. Okay, discuss with each other. Once you have it written down, show your answer. See, look what I wrote. That's cool. I drew a unicorn. Okay, ready to share answers? No. You made strong eye contact. That was your bad. Okay, share your answer, please. Say it one more time, a little bit louder. I couldn't hear it.
When the coordinates on a graph are in a function, you can connect them with a line.
Okay, good. So you can connect them with the line. So what kind of line? One that goes left to right or up and down? Okay, so what we're discovering is usually your teacher would go straight to just saying, oh, if you want to say whether it's a function or not, just use the vertical line test. I'm showing you why the vertical line test works. Okay, so you guys are now telling me that if it is not a function, that's when you would do something called the vertical line test. So basically, if I can find somewhere where I could draw a line that goes straight down, well, that's horrible. So as long as I can find one location, then this one, if it has 2 x values on here, or 2 points that have x values, the same one, then this one is not a function. It doesn't matter that I can find this a bunch of times, almost infinite many times. I only need to find it one time, and it makes it not a function. All right, let's go to our exit. So if we need the additional practice, it is from the packet. So I think we'll hold off on the additional practice if you guys can do the exit ticket. If not, then we're going to have to do the additional practice. So go ahead and test whether you understand everything from this section. You understanding this and showing me that means we won't do the additional practice and spend more time on this section. So go ahead and start that now.